In this review, we're going to study integration techniques. So we can start with integration by parts. Integration by parts. Integration by parts. Sometimes we call this is IBP or DI method. DI method. Major technique would be we know that when you do the integration by parts, it is UDV. So we have an integral, we write it like that, UDV. The formula says it is equal to UV minus VDU. So that is the formula. Your goal is to find U and V so that the second integral is easy. So this integral is easy. So that's the goal. You're going to find UV so that the second integral is easy. So for that, we're going to use a technique called the is a Layat is the argument, because the idea is how to pick which one you're going to pick as the U. So there's a kind of technique that works most of the time. Here, what is L means the log functions. So that's the log functions. I means the inverse functions, like inverse sine, inverse cosine. A means the algebraic functions. T means the trigonometric functions. And the E means the exponential functions. So that's what we call the preference order for U. So this is how we're going to pick U. Okay. So we're going to pick U in this order. So we're going to start with left to right. That's the preference order for U. Okay. Good. So let's look at some examples. Need to be clear what I'm talking about. So as a first example, let's start with this. X e to the negative 3x plus 1 dx. So it's clear that we have algebraic functions and a trigonometric functions. So that means you have to pick algebraic function as u. So that means u equal x. The rest of the function we're going to put for v. So dv is e to the negative 3x plus 1 dx. We take the derivative of the first one, so du, derivative is 1, so that means it's going to be dx. Here we integrate, so there's something that you can remember. So when you have a constant like that, we can pretty much ignore that when you do the integral. So that means it doesn't really affect the integral. So that means you simply repeat that. Okay, repeat that. So that means you need to only worry about the negative 3. We know that that's a constant. That means when you integrate, you just divide by that. So divide, that means you can write this like that. E to the, you simply repeat this part including 1. Okay, so you can see that it's a plus 1 minus 1, any constant you can simply ignore when you do that and just repeat it. Okay, so that's the u and v. Now we're gonna plug in that here. That means according to the formula, this equals uv minus v du, and we can see that we have everything now. So uv, so you're gonna multiply the two. So I'm gonna write this one as negative 1/3 x coming from u and the rest of the v, so we can write it like that. It looks good. Minus, and there's a minus sign here, so it becomes plus 1/3. I'm gonna write out, so v du, so rest of the v, so that means that's the rest of the v, and the du, we have dx. Okay, that means you have to integrate this again. So that means it is negative 1/3. So you get negative 1/3 x e negative 3x plus 1. You can divide by negative 3 again, so you can be negative 1/9 e to the negative 3x plus 1 plus c. So that's the answer. So we use the integration by parts, just the direct way. Okay, so that's the 4 parts that we need for the formula. Okay, let's do another problem. So I want to do like a different type of problems. How about this one? Let's say you have t secant t tan t dt. So if you get something like that, again, you need to be wise in how to find the u and dv. And so how to find u? So you find u, so that once you do the derivative, it's simple. And we find dv so that it's easy to integrate. And you can see it's very clear in this case. You're going to pick this one as u, and this one is dv because this part is very easy to integrate because that's a derivative of secant. That's a derivative of secant. So we can use that fact. So that means we have those two here now. So u equal t, dv equal secant t tan t dt. So if you take the derivative, you get du equal dt. If you integrate, because this is the derivative of secant t, so it is simply secant t. Okay, because secant t tan t is the derivative of secant t. If you integrate, that means you should get that. Okay, so we have the formula now. So it's very easy now. So uv, that means t secant t, and then minus vdu, that means secant t dt. Secant t, we know there's a formula for that, so it is t secant t minus, we know that it is simply natural log secant t plus tan t plus c. Okay, so that's the answer. So you can see it's very simple. So these are the u and dv. Okay, good. So let's do another one maybe with log. So how about x 5 half natural log 2x dx. Um, Now we know that I'm going to do the light argument. We're gonna pick log function as u. So that means I'm gonna rewrite. I mean, this step is not necessary, but I just write it for clarification. Dx. So this is the u function, and that's the dv. So it'd be better to put a parenthesis around here just to avoid the because that's the be careful with the multiplication. So log only goes with 2x. Okay, good. So we have u which is natural log 2x dv equal x 5 half dx. So du equal, take the derivative by the chain rule, 2x goes down, the derivative goes to the top, dx. But this is simply 1 of x dx. Here you take the integral, so you add 1, that means 7 half. I mean 2 over 7 x 5 half. No, 5 half, 7 half. Okay, so that's what you get. So we can plug in here now. So that means your answer is uv. uv means 2 7 x 5 to 7 log 2x minus and then we have 2 7 x so we have 2 7 and then that's v, and then dx is du is 1 over x dx, so we have that, and then you can see this is 2 7 x 7 half natural log 2x minus, I can pull this out and you can see you can simplify. If you simplify, you're going to get x 5 half dx. So this is very easy to integrate. So let's integrate that. So you get 2 7 x 7 half natural log 2x minus 2 7, and then you can add 1, so you can so you're gonna get 2 7 x 7 halves plus c. So if you want, you can simplify this a little bit. It's better to write it in the simplified form. So I'm writing all the steps, but some steps are not really necessary. You can do some mental calculation. Good. So that's about that. So let's do just 2 more examples. Now let's do one with more terms. Like how about this one? 2 x squared minus 3t plus 1, and then sine 3t dt. Since we have more terms, I'm going to use the di method for this one. So we got the d and the I. So it's the polynomial gonna go with the d, because once you take the derivative it looks simple, and we're gonna put the trig functions for the I. According to the light, you have to pick the polynomial first. Good. So now take the derivative of the first one. So you're going to get 4t minus 3. You can integrate. So negative 1/3 cosine 3t. Because we know that the sine integral is negative cosine, but when you have a constant, divide by the constant, but this is a negative sign conform is a sine. Okay. Now take the derivative again. So it is 2. Take the integral again. So the cosine, that means you divide by 3, that means negative 1/9 sine 3t. Take the derivative 0. This is you divide by negative 1/3, so negative, so it becomes positive now. Cosine 3t. Okay, those are the terms. And then we know that the first you start with the plus sign, and then minus, and then plus. Okay, like that. So let's multiply them. So you multiply the first two. I'm going to put the negative sign in front, and then 1/3 also in front. So we have 2 t squared minus 3t plus 1 cosine 3t. That's the first one. The second one is minus minus plus. So we have 4t. We have 4t minus 3 1/9 sine 3t, and then the last one is plus 4 over 27 cosine 3t plus c. So we will leave the answer like that. Okay, good. So let's do the just one more examples as the last one. How about this one? So e. So let's do x tan inverse x dx. So if you have a trig function, we normally pick the trig inverse trig function. We're gonna pick the inverse function as u. So that's the one of the trick that we use, and the dv is x dx. So we combine these two. Good. Take the derivative. So du equal 1/1 plus x squared dx. Here v equal x squared over 2. So we're going to plug in there. So you're going to get u v. So it is the product of the two. So x squared over 2 tan inverse x minus v du. So it is x squared over 2 1/1 plus x squared dx. And you can see that 1/2 you can pull out. X squared over 1 plus x squared you can write in a different form, so that you can what you normally do is you divide. Okay, but I'm gonna do it like as a trick, because you have x squared over 1 plus x squared. You can write this one as you add and subtract 1. You add 1 and subtract 1 over 1 plus over 1 plus x squared dx. Okay, that's clear. You add and subtract 1. Now when you add the first two terms, you get 1. From the second one you get negative 1, so that you can rewrite this. This step is not really necessary, but I'm writing it for clarification. So 1/2, you can write this one as 1 minus 1 over 1 plus x squared dx. Now it's very easy to integrate. For first one you get x, second one you get tan inverse x. So you can combine them, that tan inverse x, and you can write this one as, you can see from the second one you get positive 1/2 tan inverse x. That tan inverse this one with this, you can write the final answer as 1/2 x squared plus 1, that 1 for that, tan inverse x minus 1/2 x plus c, because you only write the one you get from there here. So that's that. Okay, so that's the answer for that. Okay, this is how you do some integration by parts problems.